All right, we are doing the cool down lesson 9 together with this video right now. So let's get to it. So we're on Unit 1, Lesson 9, Moves in Parallel. They start off by giving us this drawing here that has points A prime, B prime, and C prime are the images of 180-degree rotations of A, B, and C, respectively, around point O. So you can see there we have our A, B, and C. Whoops, nope. Let's go back there. We have our A, B, and C here, and all they did was do the 180-degree rotation, right, which, as you guys learned in the lesson, is going to give us some special relationships with the angles. Here it says, for number 1, answer questions 1 and 2 and explain your reasoning without measuring segments or angles. So we don't need a protractor for this. It says, name a segment whose length is the same as segment AO. Well, AO would be, from point A to point O. This segment right here, the one that has the same measurement of that would be A prime O, right? Because if I only did that 180-degree rotation, that's a rigid transformation, and we know that rigid transformations keep the side lengths the same, keep the lengths of lines the same, and keep angles the same. So because it's a rigid transformation, so it's a rigid transformation, and we know that that keeps the side lengths the same, right? Those corresponding sides, A to O, line AO, is the same as A prime O. Those are corresponding sides. All right, number 2, what is the measure of angle A prime O B prime? So A prime O B prime would be this angle right here. Well, I can see that A prime O B prime, because again, it's a rigid transformation and that angle got formed just by doing that 180-degree rotation, it's going to be the same as angle AOB, which is this angle right here. Okay, now it does tell us that that angle is 79 degrees, so angle A prime OB prime is also going to be 79 degrees. And again, it's for the same reason as above, right? It's that rigid transformation, and angles stay the same under rigid transformations. All right, for the next set of questions here, it says use the figure to answer questions 3 through 5. Find the measurement of each angle. Again, we don't need a protractor because, as you guys learned in that last activity for the lesson, that this shape here just got formed by doing that 180-degree rotation around point C, right? So, excuse me. When they're asking us for number 3 there, what's the measurement of angle GCD? GCD is this angle right here, and it's a vertical angle. Mrs. Bowles went over that. That's a review from last year. It's a vertical angle to angle FCH. So because angle FCH is 35 degrees, this one is also 35 degrees. Okay. The next angle that they're asking us about is DCF. Well, DCF is this angle here. And it's a supplement to that 35-degree angle, right? Because you guys can see I've got this line that goes all the way across. That's a straight angle. So the angle that we're needing to find, I'll just take 35. Whoops. Let's see if we can get that back up here. Not now. Sorry about the technical difficulties. Maybe it'll show up. Hey! We got it. We got it. I'm going to just take 180 degrees and subtract 35, and that actually gets me, try not to do that again, 145 degrees. Okay. Angle HCG this angle down here is the next one that they're asking us to find. And that's a vertical angle to the one we just found. Or yeah, that's a vertical angle to the one we just found. So that one is also 145 degrees. Now for this next set of questions, it says use a figure to answer questions 6 through 8. Find the measure of each angle. We're putting all of that together. Vertical angles, supplementary angles, all that we're going to need to answer these. The first one it asks us about is HCB. That is this angle right here. And that actually is a vertical angle to the given angle they have on there, which is 25 degrees. So because it's a vertical angle to this angle here, right, we can see how they get formed by the same set of lines. They're just on opposite sides of that vertex, point C, that they're also congruent. They are also, that one is also 25 degrees. Okay. Now angle GCD is a little bit different. So angle GCD would be GCD, be this angle right here. I'll do that in a different color. Well, for this one, I have no vertical angle to go off of. I know that the one beside it is 25 degrees, but actually that's a big help, right? Because if this angle right here is 90 degrees, that means these two angles together, right here in green there, those also have to be 90 degrees because line GF is a straight angle, right? That's 180 degrees right there. And if this one takes up 90 of that, that means the other two have to make up the other 90. Well, they're giving us the 125 degree angle. So all I need to do is subtract 25 degrees from 90, and that gets me my 65 degrees for angle GCD. And then I'll erase all that to answer the last question. The last question says angle FCH. FCH. Oh, look at that, right? This is a vertical angle to the angle we just found. They are formed from the same two lines, right? From this line here and this line here, right? So that one is congruent. They're vertical angles. It is also 65 degrees. All right, for the solving equations here at the bottom, just make sure you show your work, guys. You know to draw the wall, right? I can actually just do that for all of them right now. And then look and see what's going on. For this first one, for number 9, it's asking us to solve for x, right? So x is being multiplied by -3. I'm going to divide both sides by -3. And when I divide a positive by a negative, 4.2 divided by -3, I get -1.4. For number 10, we have something different, right? I've got -18 on the left side of my wall, but on the right side of my wall, I have 2 x terms. I can combine those, right? These are like terms right here. So -7 plus 19 is actually -12. I'm sorry, +12. So I've got 12 x's, right? -18 equals 12x. Now I see x is being multiplied by 12. Right, I simplified first, got 12x, and then I can divide both sides by 12 and actually get -1.5 for x. Look at that. -1.4 is the first answer, -1.5 is the second answer. Is the third answer going to be -1.6? Let's find out. So for number 11, same kind of idea. I've got my wall. I have the x's on the right. And then on the other side, I've got these two like terms that I can combine. -37 plus 16 is -21. So I have -21 equals 3/4 x. And I'm just going to do the opposite. To get the x by itself, it's being multiplied by 3/4. So I'm going to divide. I'm going to divide by 3/4. Now, a positive divided by a negative is a negative, so I know my answer is negative. -21 divided by 3/4 is actually -28. It wasn't -1.6. So I've got -1.4, -1.5, -28, All my answers are negative. Does that mean this one's going to be negative also? Let's find out. For this last one, we have nothing to simplify. There's no like terms. I just go ahead and see x is being multiplied by negative 1/5. I'm going to do the opposite and divide both sides by negative 1/5. And that gets me x equals, well, wouldn't you know it, it is a negative answer. X equals negative 2 1/3. And that's it for that lesson, guys. I'll zoom out so we can see those answers one more time. If you need any help with any of that, please just make sure you ask your teacher.